First thing first, I have stage fright, so if I'm shaking, ignore me. And as Code Rabbi said, learn the most by sharing your knowledge with others. So here I am. Whee! This talk is entry level, and it's about face detection. Face detection is seeing an image and then counting how many faces there are and where they are. This talk is not about face recognition. Face recognition is when you see a face and you can say, okay, that face is Michelle. And I will not go into details about algorithms. That would demand a master I wanted to get but didn't get. But what I will do is that I will give you an overview of the options that you have to implement face detection in PHP. And if that's not good enough, here's a picture of me with a dragon. I'm Michelle Sanver. I'm president of PHP Women. We're an awesome music group for everyone. We just want to create a friendly community that is nice and diverse. And I always mention that I have an accent. It's from one of these places, or all of them. I'm Swedish, lived in the Netherlands for 6 years, and now live in Switzerland, where I work at this awesome company called Leap. Has anyone heard of Leap before? Okay, cool, a few people. Leap is a web agency, and at this web agency I work with data. Data is what I do, and data is my favorite thing to do. In this, I use Elasticsearch and PHP, and I'm an expert in APIs and Symfony. Leap often has positions and no remote work, unfortunately, so you would have to move to Switzerland. It's horrible, I know. So this talk is open source. What does that mean exactly? It's the first time I give this talk, so I might be missing information. And if anyone in the audience has that information, feel free to interrupt me and say, hey, maybe you should add this. That would be cool. That would be a cool addition to the talk. Or ask questions anytime during the talk. After the talk, during the talk, it doesn't matter. I love for this to be an interactive talk. So let's talk about why we wanted face detection in the first place. Let's talk about Rocka. Rocka is an image service that delivers fast images really, really easily. As one of our customers says, Benjamin Caviezel from Freitag. Anyone knows Freitag? Okay, I guess you have been to Switzerland. So Freitag is this cool company that has a lot of bags, and they actually make it out of truck tart. So they make recycled truck tart and make unique bags. And out of these unique bags comes a lot of pictures. A lot of pictures. Every bag needs a new picture. And on pictures of websites, they used to need pictures with different formats, and it got tedious. So we helped solve it with Rocka. And also, of course, helped Migros. So how did we solve it? Basically, we have stack operations. We have this huge stack, and we can resize, crop images, and do everything in one stack, and then we cache it, and we always work on the original image. So that means if you have that header stack, you eventually go to your organization.rocka.io / your image.jpg or whatever format you have. And it delivers really, really fast. Because we use CDNs and really, really aggressive caching. But this talk is not really about Rocka. If you want to know more about Rocka, you can go to Rocka.io or talk to me afterwards. But Rocka is the reason that I started looking into face detection. So we have focal point cropping. You saw that stack with the cropping and the resizing. And currently, you have to define a focus area manually. You have to say, for instance, for fry tag, you have to say, I want to focus on these bags because these bags are important to the product. So if we crop this image, it has to go to the bag. So obviously, we want an automatic focal area, so you don't have to click every time. For the bags, you still have to do that, but for the average image, you want to focus on faces. And you don't want to focus on just one face. You want to focus, for instance, if it's a group picture, you want to draw a box around those 3 faces and make sure they're always on the picture. Pretty easy to solve, we thought. So we had an inner day. At Leap, the 10th of every month, we have a day just for innovation. Rocka, for us, is a product that came out of innovation. And at that day, we do something cool, and I thought, okay, let's do face detection in a day. Well, actually, we didn't yet implement face detection. The plan was to do that before this talk and have it done, but it got deprioritized. But I'll show you the path we took, how many beers we needed, and how we will do it now, because I got a working example. So the first idea was, we have Composer, right? And Composer has tons of packages. We'll just install one. This is really, really easy. It's probably invented elsewhere. And, you know, we have face detection in an hour before lunch, and I can do something else and just play with it. So I go to packages, search for face detection. Okay, there's a lot of irrelevant examples, but this Laravel thing looks interesting. Okay, we're using Symfony, but you know, easily enough adjusted to Symfony. And as an interruption, if anyone is colorblind and can't see my slides, let me know. And the problem with this Laravel package, after adapting it to Symfony, we noticed it only detects one face, which obviously doesn't work if you want a box around a group of people. So that took 2-3 hours. We should have looked further, but that's okay. Okay, so there's no packages that easily detect multiple faces in PHP. If anyone knows of such a package or library, let me know, because I didn't find it, and all my followers on Twitter didn't tell me. So I asked Twitter, okay, face detection in PHP, what do we do? What do we do? Yay, there's an OpenCV face detect PHP extension. That's cool. That's what we're gonna use. Right, so what's OpenCV? It's a computer vision and machine learning software library written in C++. It's a really, really nice library, and it has a community of over 47,000 people. And actually, the number of downloads is an estimate of 14 million. I guess about 1 million is me trying to install it. So the library is used extensively in companies, research groups and governments. Companies like Google, Yahoo, Microsoft are using it. Of course, you all know those companies. It's really cool. It's more than 2,500 optimized algorithms. That's a lot. Face detection is one of them. Right, so it has C++, C, Python, Java, blah, 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 interfaces, and it's really, really cool. But here's the point. PHP and OpenCV don't collaborate at the moment. There are 2 PHP extensions for OpenCV. The OpenCV extension is not yet updated to PHP 7, which was a deal breaker for us because we upgraded to PHP 7, so we couldn't use that. The face detect extension uses PHP 7, but the OpenCV it uses is outdated. But it works. If you want your beer to be a face. So if you want to use it, it's super, super, super simple to use. This is basically after installing the extension. You just use the functions, pass in a file, and then the XML you want to use. And to get the coordinates, you can do it this way. So, unfortunately, I uninstalled this extension before I took a lot of pictures of what it produced. But I could tell you I gave it a picture of my son, which is a really, really nice picture. And it thought he had 4 faces. 2 of them were on the wall. The dishwasher was a face who was in the background. Unfortunately, his face was not a face. So OpenCV uses the Viola-Jones detectors, and they are more than 15 years old. They are really, really, really outdated. And today, if we look further and further, we have a lot newer and better technologies than what they use. And they will probably be implemented in OpenCV, which is nice. We have key points, local invariant descriptors, histogram of oriented gradients, deep learning with pyramids, and the formal parts models. Actually, someone told me OpenCV is not as bad as it should be. At that point, I had already uninstalled everything and said, okay, I'm just gonna give up with this. But it is quite efficient. I installed the latest OpenCV version, and for face detection, it is trained really, really well. So it is efficient, unless you use it with the outdated PHP extension. I noticed that OpenCV is as efficient as I'm about to show you now with Dilib, which I explored after OpenCV. Dilib does not have a PHP extension. It's also open source, and it's a machine learning toolkit. With Dilib, I noticed every example image that I had showed the faces, and it didn't show a dishwasher or 2 walls. It actually showed the faces of my son. That's cool. So, if we look at an image of all the speakers at this conference, I just took it from the website. We had 23 faces detected out of 25. That is pretty cool. That is pretty good. I will show you later some other APIs and how many faces they have detected. And you will notice this is pretty cool. Considering the faces, it did not detect. So notice that it's front facial recognition. So you can see that we can't see Ben's face because he is quite not really looking into the camera at all. But we can still see Antonio's face, even though he's not looking in the camera, and Enrico's face. So it's quite efficient. Unfortunately, Graham's face is an interesting post with part of it cut off, so you can't really see him. I think that's a fair result. I think this is really good. So Dilib has a much more modern and newer algorithm. Training OpenCV takes a dataset of thousands of images, and I tried to do it on my computer, but the CPU gave up. And I have a pretty good MacBook Pro. In Dilib, I could run an example, which I'll show you, and manage to actually train it to do cool things. So Dilib uses histogram of oriented gradients liner classifies an image pyramid and sliding window detection scheme. I don't know what half of these means, but I know that histogram of oriented gradients is really modern and cool. What it does is that it goes over an image, kind of lots of boxes over the image until it finds something interesting. And eventually it makes a vector out of that. And the vector it uses to detect all the other images, and then it trains it. But now comes the problem. This is not really, really PHP at all. And I have this Symfony application, and I want this face detection and the coordinates inside of Symfony. That's actually almost too easy for a talk. Step 1, compile the C++ library. Step 2, use exec. So obviously you will need the path to the image, which you can get from your PHP application. You give it to the exec function, then you get the input, and voila. You can do anything with those coordinates, and simply use it. It's awesome, it's great. Deep learning is fun, so much fun. And there's so many things you can do with Dilib once you have it installed on your computer. I saw an example that I also tried running myself, where you train Dilib to recognize dogs. So then you get an example like this. You see the dog, and then you recognize the eyes, and you recognize the nose, and then you can hipsterize it. Because that's fun. And then you can hipsterize all the dogs. So yeah, you can do all these awesome things. Imagine having a system for cameras, speed cameras. You can detect if it's actually some crazy Swiss person going downhill on a bike rather than a car that it catches, or you can detect anything just by training it. It's a lot of fun. So we have these two really, really, really good libraries. But of course, we don't need to use libraries all the time if someone else does it for us, right? So there's Amazon recognition, which is amazing recognition. And they have object detection, moderation detection, which is pretty cool. So if you look at Amazon's object detection here, you can see that there's a skateboard, sport, people, person, human, parking. Pretty cool. It's very accurate to detect this example image that they have. But if we look at this bikini model, we can also see that the moderation detection is also pretty good. It's 83.5% suggestive, and it's a female with swimwear. Okay, pretty cool. And Ben Edmonds is not suggestive. That's good. So if we look at all these people here and the object and scene detection, we can see that 99.2% of people are it's 99.2% people, there's humans in here. And the really, really interesting part is that it can actually detect that this is a conference. I think that's cool. Only problem is we saw the result of Dilib. It had 2 faces that it did not detect. So then Amazon recognition, it should be really good at face detection, right? This is the faces it detected. That's 1 missing, 2 missing, 3 missing, 4 missing, 5 missing, 7 missing faces. I don't think that is really good face detection. But then I noticed it's because the faces are probably too small. Because when you go and you give it an image where only, for instance, Ben Edmonds is in it, it detects him. But if you give an image where only Graham is in it, it doesn't detect him. Unless you really, really zoom in and give Amazon recognition only the face. It looks like a face and has a mustache That's good. Has a beard is good. Appears to be female is not good in this case, but the interesting part that I found with Amazon recognition is that it's 100% sure someone is a female, but only 99.9% sure that someone is a male. If anyone knows why this is, it will be really interesting. Sarah is a female, I'm a female, Georgina is a female, James is only 99.9% male. Yeah, I don't know why the algorithm is not 100% sure. Of course, there's a lot of other libraries as well, like Microsoft Azure. In here, it had a lot better detection in faces than Amazon recognition. So Amazon Azure is a better library to use, well, better API to use for face detection. It's pretty nice. But still, Dilib was better. It managed to detect Marco, while none of these API services or experts in it managed. So that's kind of the options that we had and that we noticed. Where do we go from here? I would first like to show you a really small video of comparing how I experienced Dilib and OpenCV and the results in it. The circles that you will see in the video next is OpenCV, while the squares is Dilib, and that's a lot of false positives. So you can imagine how many beers I needed when these were faces. But it's pretty good at detecting the faces. You can see though that Dilib only detects faces here. Apparently Netflix has a lot of faces. Yeah, it's quite interesting. This is the first error we see Dilib do in the scan here. I guess it kinda looks like a face if you really squint. Right. So, as we can see here, these were my experiences first time I used OpenCV with the PHP extension, because it's really, really bad. And when I wrote this slide, I hadn't tried it out, the newest OpenCV, out yet on my computer without PHP in between. So OpenCV is too inaccurate for me to use and train with PHP. It's not too inaccurate to use out of the box the newest version for face detection, because it's really, really well trained. The extensions are out of date, but I happen to know someone who develops the OpenCV extension, and I'll probably help him to update it. Because it's all open source, and that's amazing. Obviously, Amazon recognition isn't open source, but if you need something that really detects if someone is smiling or things like this, you can do it with OpenCV. That's really, really tricky. It's easier to do with Dilib because it's easier to train. But then you have to give it a lot of data. And sometimes it's not worth it. But obviously Amazon recognition is not free, and this is only about face detection. So Dilib is open source, and so far had the best results in my tests. All I can say is that the title of this talk was lying a bit. Don't use PHP itself for face detection. Use Dilib or OpenCV with exec. But wait a moment, that actually gives you a problem if you have an environment where you can't compile a C++ library. What do you do then? Then you probably pay for it and use an API. There is libraries that detect just one face. So if you have a use case like that, you can use PHP out from the box. Or JavaScript, for that matter, has plenty of face detection for one face. I really, really want to update the OpenCV extension to be as efficient as it is if I install the newest version. And training OpenCV for custom detection is really, really hard. Hog that Tealip uses is modern and more accurate algorithm, so I would always use that. Now, I mentioned that this talk is open source, so I wanted to kind of ask you, anyone tried doing face detection before? Okay, how many of you had really accurate results? You had? Okay. So, after all of these alternatives, what would you do? Would you go my route and implement it in Dilib, OpenCV, or would you use an external API? Does anyone have any opinions on what you would do? Use Python. Yes, actually, both OpenCV and Dilib has connections to Python, and it's really, really easy to use in Python. And yes, in some cases, use Python, but if your entire application is built on Symfony, it's a bit tricky to rebuild everything to Python. So that's why we do this. Yeah, you can do that. For me, it's easier to write it in C++ than Python because I don't have any Python experience. But I think that basically that's a really good idea to write a connector, what I did now is write a simple C++ program that outputs the coordinates of all the faces, and then it goes back to PHP. And in PHP, you then have a box around the faces, and you set the focal area in Rocka. And with that focal area, you can crop it. It's simple, it's fast, and it works. But then, yeah. Yes. It gave about the same results as Amazon recognition. Okay. I'm going to finish this talk early because I'm out of content. I'm sorry. But thank you, and if you have any questions at all, let me know.